Greetings, this is just a very short video on how I was able to build, create a .bin file, and flash it to my microcontroller to get the Hubris operating system from Oxide computer running on my microcontroller. And this is a very uninteresting demo. I mean, I'm not hooked up to any... my microcontroller's not hooked up to anything, actually. But you go up to their website. I'm assuming you already know where it is, and that I wasn't able to build Humility, and I don't know that would even matter because, like I said, I'm not hooked up to anything. So I just use GDB. So here's how I do that, and I have my own fork. Yeah, this is my fork of the Cortex-M Quick Start. It's from the Rust embedded book. So I have so you can find that on my GitHub. What I do here is I give you explicit instructions how to set up an STM32F4 series to work with the Rust embedded book. Well, it works with Hubris also. So anyway, my name is SteveMac321. That's my username up on GitHub. Steve Mac, STEVEMAC 321. I'll put it in the description. And so what is relevant? You want to install ST-Link tools. This part doesn't matter. And then you want to install OpenOCD. And you want to install the ARM Crosscon tools. Of course, you probably already have all that. But here's what's unique, is what I do is once I build Hubris, then I go ahead and navigate to the target thumb v7em none-eabihf /release. And if you look in there, what the build gives you is a demo-stm32f4-discovery elf file. And so you can run readelf-s on it and get the section headers here. And see it has debug information and so on, and that the text section is non-zero, which is nice. So you have a program. However, you don't flash the ELF file. You keep that local, keep your symbols local, and you flash the bin file and let OpenOCD and GDB talk to each other. So this is from my website, how to generate the bin file. You use obj copy, and so then you get a nice bin file, and then rather than depend on their tools, which I couldn't get to build, I just run ST. So ST flash erase, ST flash write, and then the name of the binary, which is not this. This is my binary for the demo, but it's, ST flash write demo dash STM32F4 discovery, and then your starting address, and then flash st flash reset. Then you run this command, and it looks for your config file in different places, so don't worry about trying to get that to match up. Just run this command. So I've launched the okay, so I've launched OpenOCD, and it's listening on port 3333. So I'll go ahead and establish the connection on the GDB side. Okay, so I have a break, or it has a break here in app/demo-stm32f4-discovery source main.rs. So I don't have source available in GDB, but it does give you the full path so we can look at it. And so we're in here, and it's going to resolve to 16,000 because my board is a F4 series. Then it's going to call this and step into the kernel if you want. And you can take a look at that code too. So now we navigate out of the app folder and into the sys folder, into sys, kern, startup. And here we are in start kernel. And I think we're about here. We're in set clock frequency tick divisor. So that 16,000 number. And then after that, it looks like it generates the task table. The task table is defined in your app.toml file. Although I don't think there's, I don't know if I could create a task that prints to the console or something. I'd have to probably enable semi-hosting or something. But you know, it's just fun to get this thing running on my microcontroller. I don't know that I'm going to spend any time trying to get it to do anything in such a limited circumstances without being connected to anything. So I just keep stepping in, and now we're in the hardware specific part of set clock frequency. It's in, so before we were in the more generic, we were in sys kern source startup. Now we're in sys kern source arc /arm_m-rs. So, which is interesting. Go from the more generic to the hardware specific implementation. And it looked like what it does is there's this object that they call an atomic operation to store that tick divisor. And so now it looks like we've bounced out of all of that after it went into the atomic source code in Rust and came back out, and now we're back into main. No, back into startup in sys kern source startup. And now it's going into the Rust library code again. And so I think that concludes about as interesting as this demonstration can get. But if you at least wanted to get Hubris loaded on your board, like if you have a STM32F4 series, this is how you can do it using obj copy to make a bin, stutil to flash, write, and reset, and then open OCD to establish that connection between the on-chip debugger and GDB, and then you load the ELF file that was generated by the build with all the most debugging symbols as possible into GDB, set up that connection and communication, and then they spill out quite a bit of information where you can follow along. And while you might not get the source code popping up into the GUI here in GDB, you can navigate to it using Vim and take a look at what's going on, at least in general. So it's better than nothing. Anyway, well, I hope you find that interesting if you wanted to do that. And again, you can find my instructions here at github.com/SteveMac321.